Welcome back to the Gruber Companies. I'm Pete Gruber.
I'm Mark Schaffner, and good morning. It's time for the Gruber Morning Show.
So the picture behind us, we always like to discuss where it came from and what the prompt was. This is, again, artificial intelligence, and the prompt was, give us an image of a newsroom in the year 2050. What it came up with was a multicolored newsroom that looks like this. It's always fascinating. You get 4 of them, at least with the setting that we have.
Yeah.
And they're sometimes distinctly different, but this was our favorite one. So hope you enjoy it. Don't look like we have any questions yet.
No, but we can go ahead and get started. I was telling Pete that first thing I wanted to talk about this morning is kind of a rant almost. Business Insider came up with a article, and in that article they talk about fueling electric vehicles versus gasoline vehicles.
Okay.
They said that there is a study that was put out by Anderson Economic Group. And this study says that it's more expensive to charge an EV than it is to fill a vehicle with gas.
So we're going to have fun with that one.
Oh, yeah. Well, yeah. So here's the basics of the study. They took a look at gasoline versus residential electricity prices, commercial charging prices, and then they added tax rates on fuel and electric cars, fuel economy details, how many miles to gallon you get versus how many miles per gallon you get, plus a few other factors, they said, to compare the cost. And here's an example that they gave in the article. A Nissan Versa versus a Nissan Leaf. So I went ahead and stayed with the same manufacturer. These are the smaller electric vehicle, a fairly fuel efficient gasoline vehicle. It said the Versa over 100 miles would cost on average $9.78. And the Leaf, if you do home charging, would cost $12.55. And if you do commercial charging, it'd be about $16 for 100 miles worth of electricity.
Mm-hmm. Okay.
I'm calling BS on this one.
Okay.
Let's take a look in Phoenix. The average price per kilowatt hour in the city of Phoenix, regardless of what type of plan you have or rate or electric company, we have 2 here in Phoenix, is about 15 cents per kilowatt hour.
Okay.
For a typical electric vehicle, it's going to take somewhere between 30 and 40 kilowatts of energy to travel 100 miles. My white Tesla Model S is great. I'm 280 to 300 watts per mile, which is about 30 kilowatts. My battery electric Volvo, not quite as good. It's about 350. Other vehicles may go as high as 400 watts. I've seen the Tesla Ludicrous with the dual motor and stuff. I drove one of those, and you had driven one of those for a while, your P90D Ludicrous.
Yeah. Mm-hmm.
And I remember that one was closer to 400 watts per mile. 40 kilowatts of energy to drive 100 miles at 15 cents per kilowatt is $6.
Okay.
Not anywhere close to $12.55.
Mm-hmm.
The highest electric commercial rate that I have found anywhere is with Electrify America, and it's the non-member rate, and it's 48 cents per kilowatt of energy.
Okay.
Not cheap. In fact, for 40 kilowatts of energy, it is $19.20. So this study might not be too far off on commercial charging. If you go down to the 30 kilowatt area, where a lot of cars sit in that 300 to 350 watts per mile, you're going to go down to between $14.40 and about $16. So at or slightly below. But again, that's the non-member rate.
Mm-hmm.
All you have to do is pay $4 a month, and you get 25% off your charge.
Mm-hmm.
And if you go to the Plus membership and pay $10 a month, you get 50% off the charging rates.
Mm-hmm.
So I'm sorry, I'm just calling BS on this.
And then if you're doing home charging, it's even less.
Absolutely. For a home charger, okay, start charging at 11 o'clock at night when your power rates are 8 cents a minute instead of 15.
Right.
Or if you've got solar like I've got at my house, plug it in during the day to solar, and you're getting your electricity for free.
So the question with articles like this is, did they have a bias that they were attempting to promote, or are they just misinformed? What would be your take on this particular one?
I think they've got a bias.
Okay.
I have yet to see a lot of reporting that I would call truly independent and say, hey, we're going to throw these facts out there. We're going to do a research study. We're not totally sure where it's going to end up. Usually there is a bias where they say, we think it's cheaper to charge electric than have gas, or we think it's cheaper to fuel up with gas than it is to charge electric. And then they have what they call a confirmation bias. Then they go out and look for the facts that will support what they've already decided to conclude. And there are plenty of facts that make it easy to support either argument.
Right. Interesting. Well, thank you for sharing. Yeah.
You bet.
So, a company called Li-Cycle, Li-Cycle, started operations at its first European lithium-ion battery recycling facility. And this was in Magdeburg, Germany, which I believe is on the north side. For those of you that are in Germany watching our show, let us know exactly where that is. But it turns out that Li-Cycle is a U.S.-based company, and you did a bit of research. What did you find about the company?
Yeah, I found out that Li-Cycle was founded in 2014. They have 4 locations across the U.S. They are a Canada company, though. They were actually founded in Canada, and they have the ability right now on their U.S. locations to recycle enough lithium to make somewhere around 700 to 800,000 electric vehicle batteries a year. That's their capacity right now.
Okay. And if they are located in northern Germany, then they're near the Gigafactory in Greenheide, so that would be convenient.
Yes.
The big concern is with the adoption of electric vehicles. Well, a couple of them, of course. Do they catch fire? What will happen to the grid? And what about the all of the waste that it generates? Those are the main, talking points that we hear about EV adoption. But recycling is definitely one of the big issues. And the cool part about lithium-ion, or at least EV battery recycling at this point, is that this is high-grade ore that is reusable over and over again.
Oh, by all means. Redwood Materials, we've talked about them a number of times in the past, and they contend, J.B. Strobel and his company contend that the materials they get out of their recycling process are higher grade, higher quality than anything you can get from the refiner as a first generation.
Right. And when you compare that to ICE vehicles, where you have basically, damaging vapors coming out of a tailpipe that is gone forever and putting carbon into the atmosphere, that's a huge difference with EVs, isn't it?
Oh, yeah, by all means. We were talking on Tuesday, if you remember, about the carbon footprint of electric vehicles versus gas vehicles, and how the carbon footprint is so much larger up front because of the mining operations and the refining operations. This will change the equation completely because there's such a small carbon footprint to recycling lithium-ion.
In an earlier podcast that we had with Sandy Monroe, he had mentioned that Redwood Materials, J.B. Strobel's company, at that time, and this was like 6 months ago or so, was really looking for customers at that point. And I think you had some recent research that was done that indicated that Redwood Materials is growing and expanding. And
by all means, they had another round of funding, and I don't know that it went beyond their main investors. They have several institutional investors that have bought into the company. They had a successful round of funding, raised about $400 million in capital, and they're going to use it mainly to expand their battery recycling plant in Nevada, but they're also looking at, in that what's called the Research Triangle area of South Carolina, also looking at building a factory over there.
Interesting. Looks like we got a few questions that are starting to come in now. YouTube, Satellite TV Ireland. Okay. It is 10 o'clock in the morning where you are. It is. And if you're in Ireland, it's probably late in the day.
Yeah, I'm thinking about 5 o'clock in the afternoon, probably. So good afternoon to you and welcome.
Yeah, thank you for joining us. Instagram, Tenson Machine Vika, or Yika, Y-A-K-A. I think we should use water-powered cars or magnetic. What? Elon Musk has all the ideas. Well, the closest thing to water-powered might be hydrogen. And
hydrogen fuel cells, while they may have some promise because it's simply another way of generating electricity to power an electric motor, there's a lot of controversy with hydrogen about how it's really not that clean of a fuel. We talked about white hydrogen a couple weeks back at the Richard and I did while you were on vacation over in Europe, and how there is potential there that is untapped and kind of unknown. But I don't know. I'm a bit of a skeptic still. I still think there's an awful lot of infrastructure and things that would have to be built, a lot of complexity that you just don't have to deal with EVs.
Sure.
It's shockingly quiet over here in this corner. Normally, there's a little bit of a commentary about fusion coming up.
He must be busy, is what I'm thinking.
And
Richard.
aliens.
And aliens.
Instagram, Abhi5979. He asked, what is the average life of a car battery? And we're assuming EV battery here because your 12-volt batteries are good for a couple of years or so. And he says, why are EV cars so expensive? Well, the first part of that question is, what is the average life of an high-voltage EV car battery? We don't know yet. That's the simple answer. Again, going back to the Tesla Roadster, which was really the first multi-cell lithium-ion battery pack. There's 6,831 of those tiny little 18650 cells in that Tesla Roadster. The original design life, according to J.B. Strobel, was 10 years on that battery pack. He has two of them, by the way. And he's pleasantly surprised last year when I was talking to him, and he says, mine is still going strong, and that was 14 years at that time.
Yeah.
We simply don't know, and that design concept actually continued going into the other Tesla cars, at least, and some of the other EVs that were built after that. The only indication we have what end of life will be like for a lithium-ion 18650 multi-cell pack is the 2016 version Tesla packs that were released that used an inferior or flawed cell, which is actually developing impedance problem 8 years after they were installed in Tesla Roadsters. And the only reason people install these in their Tesla Roadsters was they were either concerned about or they were expecting that 10-year lifespan, so they wanted to get ahead of the curve, or they had bricked their car where the battery went dead, and they needed to replace it. And the symptom there is you lose power. All the cells seem to, in tandem, begin to get weaker. They have a higher impedance, and they don't have the punch and the energy density that they used to have. So we're expecting the legacy packs in the Tesla Roadster, which came out in 2008, to eventually go the same way, and that the end-of-life symptom will be a loss of power. But at this point, no one's really sure how long these 18650 lithium-ion cells will last, and it looks like the same is holding true for the 2170 cells, which came a bit after the 18650s. The other part of your question is, why are EV cars so expensive? Well, relative to ICE vehicles, they're coming fairly close. In fact, the tipping point is almost there, especially with some of the Chinese EVs, which are less expensive than the ICE cars. And of course, the expectation is with so many fewer moving parts and lower maintenance costs with an electric vehicle, we're going to see a continued decrease in the cost of electric vehicles. Where the biggest expense right now is in the high voltage battery pack. In a Tesla Model S, you're carrying around 1,200 pounds of DC battery. For a car that should weigh around, under 4,000 pounds. Eventually, as technology improves and the energy densities in DC storage improve, and if Jesse's wish comes true that we get fusion in cars, this will go away. But the problem that occurs is, in an ICE vehicle, you have a number of components where you distribute your cost. With an electric vehicle, you only have a few, and one of the big ones is that high voltage battery at about $20,000 to $22,000 for a car that's worth $30,000 to $35,000. And that's where the stigma or the impression that EV cars are very expensive comes from, I think.
I think that's part of it, very much. And yeah, go ahead, Jesse.
That's when it happens, not if. When.
When? Okay, that's right.
I also think that the EVs are suffering a little bit from the type of thing that happens all the time. Our most extreme example is in the pharmacy industry. Pharmacies will spend hundreds of millions of dollars or even billions of dollars to develop a drug, and then they have that 15-year patent on that drug, and you're paying $1,000 a month for it. At the end of that 15-year patent, generic drugs come out, and it's the same medicine, it's exactly the same formula, but you're paying $1.50. Well, it's obviously not that extreme, but you've got the research and development and beginning of building processes. A lot of inefficiencies are put in simply because you're doing your best, but you know that you're going to get better over time.
Sure.
That's a lot of what I think has happened with EVs, to price them at a higher rate than most equivalent gasoline cars. The companies simply have higher costs because they've never done it before.
Right.
Tesla is really, with the reduction in prices of the Model 3, is really showing that, hey, we're getting our economies of scale, we're getting our costs down. Now we're getting an electric vehicle that costs roughly the same as a gasoline.
Sure. And they're capturing their ROI, whereas a new startup isn't going to be able to do it at the same level.
By all means.
All right, YouTube. Martin Fisher, he says hello from Davos, Switzerland. Well, thank you for joining us.
Good morning or good afternoon to you.
Yeah, TikTok. Tommy Young, he said, not cheaper when adding cost of battery replacement every 3 to 5 years.
And I'm sure this is about my rant about refueling. And I do want to make sure that you remember, Tommy, this was just about the refueling costs, not about the battery replacement versus engine replacement. Batteries, it's the most common guess from members of the press and from those who call themselves experts, some of them are and some of them aren't, will say that an electric vehicle battery will probably last somewhere between 8 and 12 years, not 3 to 5 years. We are seeing, like you said, on the Roadsters, 15 years. We're seeing on the Model S's, plenty of Model S's that are out there as 2012, 2013, and 2014 Model S's that have completely strong batteries. And that's between 9 and 11 years, and they're still going strong.
But even if it does need a replacement in 3 years, it's got an 8-year warranty.
Good point. Yes.
Yeah,
So
very-
it's free
very
for
good
the
point.
first. Yeah.
And that's not a Tesla thing either. That's the U.S. federal government has mandated that any vehicle manufacturer that's going to make large-scale electric vehicles has to offer at least an 8-year, 100,000-mile warranty on those battery systems.
I did not know that.
Yeah.
Interesting. Okay. Question from YouTube. Highland Apparel, welcome back. He said, do you guys use thermal imaging for troubleshooting? In essence, Fluke or FLIR? Good question. Yesterday, the service manager at Gruber Motor Company called me over. He says, one of our circuit breaker panels is real hot. And I thought, well, what could be causing that? So I walked over, and we have large 400 amp breaker panels, and where there isn't a breaker, there are these little, inserts to cap off the gap. So I popped one of those in the middle just for the heck of it, and I saw a little glow inside the breaker panel, almost like there was a little incandescent bulb in there.
Oh boy.
Yeah, exactly. And Victor, what is causing it? I said, well, it looks like we've got arcing. And sure enough, we took the front cover off, and on a 50 amp breaker, we had a loose screw onto the bus bar, and it had begun to arc, and it had heated up the whole panel.
Okay.
In that scenario, of course, using thermal imaging would have told us that there was a problem probably before it started to glow.
Probably.
Yeah, and that's one of the uses for it. But I think the question is more related to, do we use it in our service of electric vehicles? And the simple answer is we have begun to do so. We actually have a device. Richard, maybe you can help me here. It's a cell phone attachment that we got from a vendor who we can give a plug to at this point.
Yeah, we got a little, I think it's TS2 Plus camera from Infrared. Infrared develops a whole host of infrared FLIR cameras or systems. Everything from working in a shop like ours. They make optics for rifles, for hunting, for photography, for
This one just hooks up to your cell phone, right?
correct. Yeah, the one we have just literally plugs right into the cell phone, and now your cell phone has thermal imaging.
Mm-hmm. So what our goal with this device was to begin to use it on the EVs as we're troubleshooting. The first thing we did was we opened up a Tesla Roadster power electronics module, and you've got just an array of circuit boards that are now exposed and visible. And what was interesting is on the higher end boards, like the PEC board, DMC board, where you've got LSI chips, you could see the heat signature on those chips.
Wow.
Now, the trick now is going to be to develop some benchmarks. How much heat are we expecting on a known good power electronics module?
Right.
And we're still working on that process to begin to use this as a troubleshooting aid. Where the real gift with this device was going to be was in the work on batteries, multi-cell battery sheets. In a Tesla Roadster, you essentially have a sheet that weighs about 120 pounds. There are 11 of them in a car or in a pack. They have 621 18650 lithium-ion cells on each sheet, combination of parallel and serial connected cells. And typically a failure that will occur is you get one cell out of 6,831 that goes resistive. When that happens, it is connected in parallel with 68 other cells in a brick. And what it begins to do is drain that brick. And then the battery safety management system comes into play, and it says, oh, we've got a problem. We're not going to allow full charging, because if we do, we're going to get a fire, So the way that we have been isolating these resistive cells is not through FLIR or through thermal imaging, because we found that the bloom is just too large. It's very difficult to isolate it down to a single cell using thermal imaging.
Okay.
Although in theory, you would think that that would work, because if you have one cell that is draining the other cells, it's drawing more current than the other ones, you should be able to see that as a heat signature.
Yeah, you would think. I mean, we are able to use software to get that 6,900 plus cells all the way down to that one brick of 69 cells.
The brick, yeah.
And then it's a matter of testing those 69. If in theory, if the thermal imaging camera can get that bloom designated down to a dozen or so of those 69 cells, you've just cut your work by 75% again.
Right. And if it can narrow it down to one cell, then of course you're basically doing what we're doing with a different proprietary method at this point in time.
Right.
Another issue we ran into with those was the Roadster sheets, as reflective as they are, was reflecting my heat signature and the heat signature of the camera back to us from the battery sheet too. So there's a lot of interference.
Because those bonding plates are metal, they're polished somewhat, and they are reflective, and they will pick up heat. So that's the answer to, are we using thermal imaging? We've not closed that chapter at this point, because it would certainly be a great way to help isolate. But at this point, we have not had great success with it, but we're still experimenting with it.
On YouTube, Niles is with us this morning, and good afternoon, Niles, because I know you're over in the Netherlands.
Denmark.
Denmark, I'm sorry.
He's going to correct you if you say that.
Yes, that's right. That's right. He says, by Google Map, there is some 120 kilometers between Magdeburg and Greenheid.
Okay. All right. Still close enough, though, for transport of cells.
Yeah, that would be pretty easy transport.
Okay. TikTok JR asks, what will be the impact of those customers with 8-year warranty that have structural battery packs? Okay, that's another
That's
great
a
question.
Great question.
You know, during the 8-year period, Tesla is going to be on the hook to replace that pack. And at the service centers, they don't dig into packs and repair them. They're just simply not equipped to do it at that level.
Right.
Once they go back to Lathrop, California, which is where all of their EV battery packs go back to, then they do refurbishment. And they're certainly not sharing at this point how they're going to refurbish or if at all structural battery packs.
I'm wondering, with Redwood Materials being so close, they've got that big facility over in Nevada. Maybe they stop sending these packs to Lathrop and they simply send them to Nevada, run them through Redwood Materials, and just make new batteries.
Yeah, that's possible.
That would be a pretty big impact, though.
Yeah. And of course, you have to consider which is more cost effective, scrapping that $20,000 battery pack or finding a way to get into that pink compound and repairing that battery pack.
That's a great question. And I know that we're not going to know until we start seeing those, and we won't start seeing those for another 7 or 8 years.
Yeah. And the simple reason, because that question will come up, is the reason we don't see things like that is because of that 8-year warranty. No one sends us warranted product or vehicles,
right?
Because we aren't the source of warranty and we have to bill for any work that we do. Eventually, I think the EV manufacturers, including Tesla, are going to outsource some of their service. You know, Tesla has already done that with their with anything like body and paint work. They've actually certified and authorized body shops to do that type of work. And eventually, as the service delivery continues to fail to grow at the pace that production is growing, they're going to have to outsource the companies that are skilled in working on EVs.
I foresee an absolute tidal wave of service coming up for Tesla in about 2 years, which is about the time that the powertrain warranties and stuff for the Model 3s in mass production in 2020 will start coming off a warranty.
Yep. Yeah, I agree. And then, of course, you have your new EV the new EV manufacturers that aren't going to be able to scale their service delivery as quickly as they do production.
Yeah, not everybody is going to be Tesla or Rivian trying to put together their own service centers.
Yeah.
There'll be, I know we've had one come to us and inquire about having us become an official service center. I'm sure there will be others.
And, you know, the reason wasn't because they felt it'd be more expedient for them to develop their own service delivery. It was because they had no options. They had to develop their own service because no one was out there yet doing this type of work on the independent level.
On YouTube, Highlander Apparel has responded. He says, yep, I get it.
Okay. We've got Facebook, Zia Learning Academy says, how are you, sir? Well, we're great. Thank you.
Thank you.
He says, I'm your special follower and taking keen interest in your brand and designing. I've shared some brands you designed here in your company, and the most interesting is that my followers love your brand. He's in Pakistan. Okay, I did not get that initially. Well, thank you for joining us. You're a long ways away. Appreciate it.
Thank you. On YouTube, Niles from the Bion Danish Genome Institute, see, I should have known right from the name, has come back, and he says, what is the value of a pack that gets replaced? Don't they have some value since they could be used for stationary storage or even recycling?
You know, the best barometer for that, Niles, is eBay. They do sell both packs and more commonly modules out of packs on eBay. And there are a number of applications for those. You're right. Stationary power is a big one. Experimenters use them. There's a company in Florida that converts golf carts by using Tesla Model S modules. Our concern is, are they doing anything about thermal management?
That's a great question.
And yeah, I mean, it's not that difficult. The voltage coming out of a Tesla Model S pack is 22.5 volts or in that neighborhood. A standard golf cart needs 36 volts. So I think with some tweaking and modification and rerouting in a module, you can, with a series parallel combination, get the desired voltage.
Yeah, and
history of
I think it would be pretty easy to do with those Model S packs as well, because there's 6 bricks in a pack,
Mhm.
which means that you're running just a little bit less than 4 volts a brick. And so you take 1.5 packs and put them together in series. Now you've got your 36 volts.
Yeah. A couple of people that come to mind, Jason Hughes in, I think, North Carolina, has been taking Tesla Model S modules for years and putting them into solar applications. They essentially
Mhm.
take the modules, stack them in a battery cabinet, kind of like we use in critical power,
Right.
and then repurpose them into solar applications. Jack Ricard, who passed a couple of years ago or so, he was telling me a story that he was doing that very thing using the Tesla Model S modules inside a battery cabinet that they purchased with heavy shelves, because you have quite a bit of weight.
Mhm.
And he was sending these down to Central America, Nicaragua, I believe, for remote locations up on mountaintops where these wealthy people lived in mansions. And it sounded fairly suspect. But, I mean, who's off the grid? Who has a mansion in that type of an area? But again, there was an application or a repurposing of these packs.
That does sound kind of suspicious to me as well. I've got, I've had a number of friends that'll travel down to Mexico and Central America, and then what they always come back and tell me is that all the poor people live up on the mountains.
Really? Okay.
It's kind of the reverse of what we have here in the States.
Right.
The higher up you go on the mountainside, the poorer the people are, because it's harder to walk up and down all the long hills.
Oh, okay.
And so the people who are more wealthy get the premium spots, and the most wealthy people are actually down on the flatlands nearest to the cities.
Closest to the roads and closest to the infrastructure. Yeah, that is
Uh-huh.
kind of inverted here in
Uh-huh.
our country because we put roads up on these mountains.
Yeah, we put roads up everywhere, and people pay for the views, and they're doing the opposite.
Interesting. Yeah. All right. YouTube, Crunch Grace, DeGrace Hopper is back with us. Thank you. He says, number 6, catching up, little fire symbol or explosion symbol, and some thumbs up.
Yep, smash that like button. So thank you, Crunch. Glad to see you back today.
So, guys, if we could pop up an image of Elon Musk and Jim Farley, and I always get a chuckle out of how people are able to grab images of these famous people and combine them into something that makes or that tells the story. And what we have here is, it looks like those two guys are having some sort of a feud, or one is confused and the other one is amused. But anyway, this is an article that I found. It says, where Tesla sits right now reminds Jim Farley from Ford of the early days of his own auto company. And he's taken issue with Tesla's willingness to continue to do price reductions on their vehicles. And Jim's basic feeling is that this isn't going to work, because when you begin to turn your product into a commodity, it becomes more about price rather than value and benefits. So he doesn't think this is going to be a successful strategy, although for Tesla it appears to be enormously successful, because I'm not sure they needed to increase demand for their product. It was already pretty heavy.
Right.
But they had some profits, and Elon decided to position, and so far it seems to have been working well in that they continue to grab market share.
Well, you know how much I like history, and how often I have brought stuff up from history here to say, hey, we're just repeating what's gone on in the past. So when I saw Jim Farley bring up history, I thought, I've got to find out the story. So I took a fair amount of time to look this up, and I feel like I dug up a few interesting things. First, yeah, there are some parallels. You've got Henry Ford. When he was young, he actually went bankrupt twice. First, after he invented the quadricycle and the Detroit Automotive Company, and again he founded after going bankrupt, he founded the Henry Ford Company, and he failed to properly brand and market his vehicles that time. They were more of an automobile type vehicle, and ended up going bankrupt again. After that, he again tried to learn from his mistakes, and he founded what we now know as Ford Motor Company. and produced the Model A, and the rest is history, kind of. When Farley made his comments, he kind of failed to take into account some of the underlying things that were going on, though. And there are actually a lot more differences between what Tesla's doing now and what Ford did in the late 1910s and early 1920s when it did drop the price of its Model Ts so drastically. In 1919, Henry Ford was in a legal battle with the Dodge brothers. We know them as, Dodge or Stellantis now.
Right.
The Dodge brothers were shareholders in Ford Motor Company, and they wanted Henry to pay dividends to them. Basically, they wanted to start their own company.
Mm-hmm.
And Henry had the practice of taking all of the profits from the company and plowing it right back into the company to help it grow.
Mm-hmm.
After a fairly long, protracted court battle, the Dodge brothers won. So Henry, upset as he was because the court ordered him to pay a $19.5 million dividend.
Which was a princely sum back then. We're
Oh,
talking about 100
yeah.
years ago plus.
We're talking about something along the lines of about 25% of the value of the company
Mm-hmm.
as a dividend. Henry Ford said, I'm just going to buy everybody out and take this company private. And so he did so. He took out loans for over $60 million, bought out the Dodge brothers, bought out the other shareholders, and then as the sole owner of Ford Motor Company, took the company private. Right after he did that in 2020, the federal government decided that inflation was too high and they needed to fight inflation. That's not unlike what the Federal Reserve has been doing here in the U.S. in the last 2 years. In this case, though, the federal government simply said, our best method to fight inflation is to not spend money.
Okay.
So the U.S. government undertook an austerity plan, cutting their budget by $6 billion, which at the time I think represented something between 20 and 30% of all government spending.
Can I interrupt you for a second?
Yes.
So you're telling me that the federal government at some point in history, 100 years ago, learned that the best way to fight inflation is to stop spending money?
Yeah.
Okay.
Can you believe that? I wish that our government people could look into history just a little bit.
Had to add that.
Yes. So in response to the recession that hit like a ton of bricks in the middle of 2020, in the summer of 2020, Henry Ford dropped the price of the Model T because sales tanked.
Mm-hmm.
People who were interested in buying this new Model T Ford suddenly said, that old Model A that I have, it's probably going to be okay for another couple of years. And so sales dried up.
Mm-hmm.
And Henry Ford was awash in debt as a result of this court case.
Right.
So, so he almost went bankrupt.
Again.
Yeah.
Yeah.
In this case, he got out of the bankruptcy by actually hiring a gentleman named Ernest Kanzler. Henry knew Ernest. Ernest ran a tractor company called the Fordson Tractor Company and had developed a technique where he did not bring inventory into the company until he needed it. So he would coordinate his orders with his suppliers so that product would arrive, raw materials would arrive right at the time that he needed it, and then he would build his tractors and send them out. Ford had Ernest do this because he was sitting on almost $90 million of inventory, and that's how he got out of his financial troubles. So for over the next couple of years, he didn't buy anything because he didn't need anything,
right.
And they invented just-in-time inventory
Back then.
back then. Now, to give you some perspective, here are some of the differences after telling that little bit of story. First, Ford was an automaker. They had Model T, they had Model A. That's all they did. Tesla has a diversified portfolio. Just in the mega pack, stationary battery systems, Tesla does several $1 billion a year of sales. So in addition to the mega packs, Tesla owns probably the largest and most reliable electric vehicle charging network in the nation, which is also a cash cow for them at this point. And they have several models of cars. Second, The price cuts that Tesla has made to spur demand are not in response to a recession. Tesla wants to capture more market share. They realize that the electric vehicle market is a young market, that many of the early adopters now have their electric vehicles, and they're trying to position their car to be more appealing to
More
the
mainstream.
mass market
Right.
of people who aren't interested in electric. They just want the best value car for the money, regardless of what fuel type it has.
Mm-hmm.
Third, Tesla has been putting in cost-cutting measures. Ford put in its cost-cutting measures after the recession, after they almost went bankrupt. Tesla was doing this a long time ago. If you remember Tesla's Investor Day, they said they already have cut the cost of producing a Model 3 in half.
Mm-hmm.
And this is before they did any of these price reductions. So they've already got their profit margins safe, and now they're reducing the price to try to go to the mass market. And finally, the debt question. Ford's debt of $60 million represented half of the company's value.
Wow.
So if it were Tesla, just to give you a perspective, Tesla would have to be sitting on nearly $500 billion in debt.
In debt, yeah.
In order to have the same percentage of debt that Ford had. Tesla right now has 0.1% of its company value wrapped up in long-term debt. So basically they have no debt.
Right.
So those are some really important differences, and that kind of concludes my rant here too, or history lesson here. Tesla is not in any danger.
Mm-hmm.
I think it's a smart thing they're doing. That this is an early market. It's a growing market, just like automobiles were back then. But unlike Ford, Tesla is going to really be able to grow and continue to take over the world.
Well, I think we're going to have to send this podcast to Jim Farley. What do you think?
Yeah, I was going to say, Aaron, we're going to put that out as a clip.
Yeah, definitely. Special message to Jim.
Yes.
Few questions coming in. Ed Prelitz is back with us from YouTube. Welcome, Ed. He said, suggest trying a mica sheet with a quarter-sized hole cut into that can be placed on the brick and slide freely against the brick chassis. Talking about the thermal imaging again, with the FLIR phone attachment a foot or so away. What do you think of that, Richard? A mica sheet.
I think we have extra sheets of mica, don't we? Because the Model S battery packs, those top,
yes,
those are made of mica.
Yeah.
If we have an extra one of those, we can drill a hole in it and test it out.
We're going to try that.
It's magnetic, right? Or does it have magnets on it, or is it magnetic just period?
Those are spacers, those little round things you're talking
Yeah.
about. But yeah, we'll just we'll use a clean portion of that sheet, or something else. But I think that's a great idea, because that way we eliminate the bloom or the radiated heat that is hitting that camera lens.
The only thing I'm thinking of is then we'll have to. There's going to have to be a strong enough visual difference between a fully functioning cell and the resistive cell for us to be able to compare while looking at one than the other. It can't be a minor difference visually.
Okay. Ed, great idea.
That's a great idea.
I wish you were still working here. We'd bring you over to GMC and turn you loose. Ed used to be the one of the service in our service operations for Gruber Power Services.
Mm-hmm.
And a service coordinator. Did a great job with our customers and with our field engineers. YouTube, Highland Apparel has come back. He says, I'm interested in being a service center, would need advice, trying to set up and position as a renewable energy office in Oregon, Ohio. We get asked this all the time, Highland Apparel. Are we able to franchise? Are we willing to bring in people to do training? Or are we willing to open up offices in other parts of the world or the U.S.? At this point in time, the answer to that is no. There is a serious manpower shortage for people that are skilled at doing the type of work that we do. And it goes beyond the level that is at the OEMs, for example, where they're basically doing module swapping. The type of work that we do in the independent space requires a number of skills, from software to electronics and to wrenching. And finding that those three in one package has been difficult for us. But eventually we will scale. We may have a franchise package, but certainly not this year.
The idea of where you want to go, I think, is a great idea. It's an underserved market. But to your point, Pete, he's going to need to find somebody who has an electrical engineering degree. That's probably the most important piece. He's going to have to find somebody who is both a mechanic and has either a software or technology bent, because many mechanics are by choice technologically ignorant. They don't want to know a lot about computers or about software. You're going to have to find a mechanic that does want to know about that, and probably will end up having to find somebody who is more of a software or computer information systems or computer programming type of degree, with an emphasis on Linux and Unix and CAN bus systems and things like that. And that's a hard ask.
It is, yeah.
Even to find just 3 people with that's a hard ask. From there, Highlander Apparel is probably going to have to spend some time and effort and investment, just learning and getting his hands dirty.
It's the same process we went through. It was trial and error. We ended up buying some EVs, a variety of brands actually, from a local testing agency that essentially did semi-destructive testing and ended up with vehicles. And we started buying those from them and then putting them back on the road. There's an enormous amount of learning with OJT, but it's a long slog, slow learning curve process. Eventually there will be schools that will be dedicated to this kind of repair. The difficulty there again is going to be the landscape is moving rapidly. The technology is changing rapidly. And to try to pin anything down at this level of disruption is going to be tough.
Definitely will be. YouTube, Ed Prelitz is back again with another comment for us. Says, you may be able to insulate and isolate each cell and mitigate the bloom and reflective heat enough to quickly isolate the cell. This is a follow-up to his comment with the mica. I totally agree with you.
One of the problems with the Tesla Roadster, by the way, for the sheets that we talked about, and you have bricks in a sheet, they have bonding plates that are that connect the cells together, both series and parallel. And there is a fusible link wire that is applied to the cell on both sides, plus and minus, to the bonding plate with an ultrasonic welder. In order to do any kind of individual work, like replacing a cell, for example, taking it out of that circuit, removing it, requires the removal of those bonding plates. And there are a couple hundred connections between the two of them. And then you have to have a $50,000 ultrasonic welder in order to reestablish your fusible link connections. So, there's some daunting engineering challenges. The reason we haven't gone that route is because we have a proprietary method that allows us to isolate that one resistive cell. And we've been very successful with that. We've had almost 100% success rate with that. So we're going to continue with that for now, at least.
Patty Ban on TikTok has joined us this morning.
Welcome.
He says, how will the recycling process be done when the batteries are done in Tesla vehicles?
Being done in Tesla vehicles, structural battery pack?
I'm thinking he's asking both about the structural battery pack and how would you go about taking a lithium-ion battery pack out of a Tesla Model S or a Roadster or any others,
sure,
and getting that recycled. We don't know a lot of the details about that. However, we do believe that based on what Redwood Materials has put out publicly, a lot of it's going to be a chemical process. So they're going to essentially run that battery through some sort of a crusher to break down the components into the original ore, and that ore is going to be comprised of all the different battery components. And from there, they're going to start putting that raw material, as it were, through different types of chemical baths that will extract each of the elements out, not unlike a leach pond for copper.
Right. YouTube, Zia Learning Academy. He says, a lot of thanks, sir, for your kind words and expression. You're more than welcome. YouTube, Highland Apparel says, wow, so informative. Thank you. YouTube, Highland Apparel, he says, I think FO4DOSON is English. That must have been someone that came in earlier.
Fordson. I think he was talking about what Mark said. Or somebody said Fordson. Wasn't that a company we were talking about?
Yes,
Oh,
Fordson
Fordson.
Tractors.
Okay, so we got a typo in there. Remember?
Yeah, that's the and Pete.
Yes.
Yeah, the Ron Burgundy.
I am Ron Burgundy. I'm going to read what you type.
and Pete, one other thing too. Highlander is our guy. So you keep calling him Highland Apparel. It's Highlander Apparel.
Highlander Apparel.
Very
okay.
regular commenter. We should probably just.
Yeah, we should correct that.
Well, we'll do our best.
Yeah.
And then go ahead.
Okay, Niles is back from Denmark. He says, well, Ford reduced prices several times, not just in response to recession. Removing waste was a continuous process. He also invented service stations from which there was revenue. Interesting. Thank you for that additional input. Yeah, Henry Ford was definitely an interesting character.
Oh, by all means. And Niles went on to say, I think the lowest price of a Model T was in 1925. It was around $290.
Wow.
Well, it sounds cheap, but remember, this is $1920.
I read his fascinating books twice, and whenever Musk speaks, I'm thinking Ford would have done that too. Niles, you are very correct. There was so much more beyond what I did research for in this particular case. I think the Model T went down to around $600 in the early 1920s.
Right.
And then as a result of the just-in-time inventory revolution, I know that he went from 15 people to build a Ford down to 9 people to build a Ford. And so the resulting reduction in labor allowed him to further reduce prices. He wanted everybody to have a car. So,
just looking at Niles's comment, the first thought that crossed my mind, is it possible that Elon Musk is a reincarnation of Henry Ford?
I tell you, there's a possibility
Some
there.
similarities there, huh?
There's the determination that Henry Ford had was absolutely remarkable, and I'm not sure that I've seen that kind of determination, at least in the automotive industry, until Elon came around.
Yeah. You know, there was a bit of absurdity and craziness in his style as well, which was, and I'm going to paraphrase here, but I think he developed a special committee within the Ford companies that actually measured the personal lives of employees, and they had to meet a certain standard of moral, a moral barometer, and if they failed, they got fired. And he actually sent people to their homes to take these types of measurements.
Wow.
Yeah, it's...
that's cool stuff, just to hear about it. I'm sure it had to be probably very frightening to the people at the time, but it sounds like it's the precursor to some of the psychological tests that companies will give today.
Sure, very dictatorial and yeah. YouTube, to be announced, is joining us. He says, good afternoon, gentlemen. Thank you.
Good afternoon. And Joel1031 on TikTok says, you can't crunch them. They will explode with oxygen. I worked at Rivian, and they have a very violent reaction when crushed. So this is talking about crushing the lithium-ion batteries.
Right, the cells.
The best thing to do is to just salvage the good ones and put them on solar parts to store power. Joel, that's an interesting take. I can see why the electrolyte, that liquid electrolyte inside lithium ion is so flammable. I could see that anything that would cause a sudden increase in heat could cause that electrolyte to catch fire.
You know, I just had a flash here. I thought the same thing. Do they discharge the batteries before they crush them? And, you know, can you crush it? Does that create any kind of a chemical reaction? Working for Rivian apparently gave him some experience in that category. But it just occurred to me, wouldn't it be great, guys, if we could get J.B. Strobel on this podcast to answer some of these types of questions? We get asked questions all the time about recycling, Redwood materials, and I think JB would make an excellent guest. Why don't you guys work on that? We'll see if we can. We've got his number. Yeah, let's talk to him. All right, TikTok. Young Lion just joined us. He says, how much is Model T in today's dollar? Well, he's our CFO. He can do this in his head.
I don't know that I can do it in my head, but I'm going to find out. It's so $1925.
It was 290. You said, because I did just a basic Google search. It still doesn't seem like it's that much. It's like $5,000, but that's just on a basic Google search. I'm not sure what your numbers are over there.
So if we do 1925 to 2023, $1 in 1925 is worth about $17.50 today. So if you take, I'm going to just say $300 because that's a little easier, times 1750, it comes up to, like you said, Jesse, about $5,250.
That's a cheap car.
That's a cheap car.
And of course, that was the original intent of that car, was to make it affordable and replace horse and buggy back then, which again, getting back to the Elon and Ford parallels, I mean, Elon's mission is to get rid of ICE vehicles and to make the EVs affordable enough to be able to foster that.
That's right. That just like Ford was, Elon has that same type of mission.
Yeah. YouTube, Highlander Apparel, thank you for correcting me. I got it right that time. He says, guys, I am a German Scot. I wear a kilt weekly.
Oh,
All right.
Awesome. That's awesome.
Yes.
Niles from Bion Danish Genome Institute, another comment for us. He said Ford also had scale. I think they made 8,000 cars a day in 1925. I'm sure Musk has read his books.
Yeah.
You know what? As always, Niles, great comment.
Yeah. Yeah, the assembly line. That was a Ford innovation, was it not?
Yes, Ford invented the assembly line as well.
Yeah. All right, I've got a news item here. We've gotten through most of the questions here. Battery swapping came up again this week. And there are a few summaries here that I took from this article. They say battery swapping technology is complex and costly. We did a video, actually, that talked about that. Those of you interested, by the way, it's on our YouTube channel, Gruber Motors. And it's about a 10-minute or so educational video on what is battery swapping all about and what are the pros and cons. But what they're saying here is it makes it unappealing for most automakers who are instead focusing on optimizing fast charging technology. And, with the federal programs now and, the NAC standard being adopted and having something that is standardized, that will just intensify. They also say that, battery swapping stations require a vast inventory of various types of batteries. Good point. Extensive maintenance and complicated hardware and software, making them difficult to maintain. We spoke briefly to Kyle Connor, who was in Norway at one point and had a rental car. It was an EV, and he actually took one of these to a battery swapping station. It was winter. You could see the snow outside.
I remember that, yeah.
And I remember looking at this and saying, you have this one stall process here, and there have to be some engineering challenges here. You've got a very heavy battery pack, at least 1,000 pounds. You've got all these hydraulics and all of these alignment issues, and and then of course the difference in climates. They may have just gone through a bunch of snow and slush, so you're going to have water dripping on this apparatus and salt, most likely, right? And then the final part of it was he was in and out within about 8 to 10 minutes or so. And he himself pointed out, there's a charging station that's attached to the building. Would it have been faster to just simply use that charging station? Maybe not for an unoccupied bay, but what if they had to wait in line to have their battery swap done? By that time, it might have been faster just simply getting a charge, So, but anyway, complicated, making them difficult to maintain. I could certainly see that. And then finally, they say, what are some of the benefits? Well, battery swapping offers the benefits of faster charge times, getting back on the road. Again, if the stall's empty and you're the only one there. There is relief from battery decay and maintenance. Now, this is still an unanswered question for me. How do you make sure that you get a good battery every time. And if you've been taking very good care of your battery, are you willing to let that go and get somebody else's headache? You know,
Right.
because you don't
Right.
know who the previous person that deposited that battery was. Were they doing Uber all the time? Was it a taxi cab? Were they, going through multiple charge cycles, much more than yours? So the quality of the battery is definitely a concern. And then the ability to easily replace degraded batteries in this process. Well, I'm not sure what they quite meant by that. And again, it depends on the program that you sign up for if you're going for this battery swapping.
Sure.
And then it's unlikely to become widespread, they say, due to the resistance from manufacturers and the growing availability of charging stations. The only pro that I heard about these charging stations was in China. And apparently, a couple of things came into play there. One is a Chinese mentality that they always want a full tank of gas.
Mm-hmm.
And in this case, you would definitely get that each time.
Mm-hmm.
And then the second is that they also had a high degree of populations in urban environments without parking. And so, garages and charging stations.
Right.
And this sort of a thing would definitely lend itself better to that kind of lack of infrastructure.
I could also see in a culture where people are not quite so ownership oriented. I mean, here in the United States, we are an ownership oriented culture. It took just on something as simple as music. The United States lagged behind much of the world in the adoption of things like Spotify streaming services because people wanted to own their albums. They wanted to have that physical piece of something.
Right.
And it wasn't until the service got to where it was truly not just equal to, but superior to what was offered alternatively before people began to say, okay, I guess this works. The same type of thing goes on with batteries.
Mm-hmm.
I'm like you. I mean, I have a hard time even going to the propane tank exchange because I take care of my tanks. I don't want to buy somebody else's problem.
Right.
I'm more likely to buy something new. It's going to be multiplied that much more for batteries. I don't ever want to change out the battery that I own as part of my car because what problems am I going to be picking up that because this is a complicated piece of equipment.
Yeah.
And and I know if I have any kind of problem and I can swap my battery for free, then I'm just going to get rid of my problem and give it to somebody else.
Right. You just mentioned something funny and something popped in my head. We are an ownership-oriented society. I can remember having a LP album collection,
Mm-hmm.
which then migrated to an 8-track collection,
Mm-hmm.
which then migrated to a cassette collection. And now I've got, hundreds, if not a couple thousand CDs, which are now worthless as well.
Right.
So, I think that ownership mentality didn't serve me well. Although back in the day, we didn't have Spotify. We didn't have,
we didn't have anything like
storage
that.
methods,
And
yeah.
so just that whole cultural thing will make it pretty much impossible, I think, here in the U.S. But the alternative is so easy. When we talk about Sweden is developing a highway where you can charge inductively while you're driving down the road. We're going to talk about Tesla and inductive charging probably later today.
So, Mark,
Yes.
what if it dropped the cost though, $15,000 or $20,000, and the company that was housing all the battery swap stations was responsible for all the battery costs? That's the only way I could see it being viable. But again, like you said, I'm with you on the wireless charging, and even more crazy things like fusion. But
you just hit on the point that you and I both talk about frequently. What about all the other technologies, the solar and the fusion and the inductive charging and all the things that are going to make us needing a 1,000-pound, 100 kilowatt or 150 kilowatt battery unnecessary in the future?
Right.
It won't matter as much. I just don't see this taking off. I just don't see where it'll ever work.
We have a picture that we can pop up. Maybe this is a good time to go into the wireless charging portion. It's in the folder there, Jesse. And it turns out that Tesla has completed the acquisition of a wireless charging company called Wiferion. Wiferion.
I think it's Wiferion, yeah.
Yeah. And so anyway, you had some information. Let's let you run with that one.
Well, yeah, Wiferion is a small German or medium-sized German-based wireless charging company, and Tesla had been working on the purchase of this company for probably a little over a year now, and it has hit the news this week that Tesla was able to successfully complete the purchase of Wiferion. Now, the application of this wireless charging is still kind of to be determined. This is one of those cases where you have a large company that's kind of just swallowing a small company in comparative size, but the possibilities are really, really exciting. The idea, I think, is that Tesla wants to be able to give people the ability to pull their car into their garage in the evening, just like they would with a gasoline car, and they don't have to do anything.
Right.
They just get out of the car, close the door, walk in the house, and they're done. And the next morning they come back and the car is fully charged.
And forget the next standard. It's no longer necessary.
Yeah, forget the next standard. The next thing on top of that is like we're talking about, you've got the highways that like the one that's being built in Sweden. We've talked about before the idea of bus stations.
Mhm.
A bus is with an electric battery, has a large charging pad sitting underneath every single bus stop, and so they go and they drive a quarter of a mile, and then they're charging again. Then they drive a quarter mile, and they never run out of charge.
Sure.
Or you go to a public parking stall, and your car communicates with Wiferion charger. You don't have to do anything. You just pull in and plug, and you come back a half hour later or an hour later from your restaurant meal or from shopping at the mall, and your car has more charge than when you left.
Mm-hmm.
The possibilities are incredibly exciting here. And so there's some of the discussion that was associated with this Wiferion is also just as fascinating. There is optimistically as little as 6% loss in the inductive charging.
Mm-hmm.
Pessimistically, people are saying there could be as much as 30% electricity loss.
Mm-hmm.
If it's on the optimistic side, if they're at 6% loss, the electricity loss in a charging cable is usually between 3 and 4%. So it's a minimal amount of loss compared to just plugging in your car.
Mm-hmm.
Very, very cool stuff.
And what we're talking about here is proximity. You essentially have two coils of wire, and the closer they are, of course, the lower your line loss is going to be. And we should probably talk a bit about what's happening. How does it work?
Mm-hmm.
The basic principles of alternating current is that you have a magnetic field that grows and collapses 60 times a second in a coil of wire. That magnetic field, as it cuts across an unconnected coil, induces current in that coil, equal to the voltage and the current in the primary coil.
Okay.
With some loss, because nothing is 100% efficient, but,
Right.
Negligible. So that's how a transformer works. You basically have two coils of wire, and as the magnetic field goes plus and grows, and then decays again and goes minus, those magnetic lines of flux are cutting across this passive coil that's sitting right next to it in a transformer, and you get this transfer of energy. So what we're doing here is we're getting rid of the magnetic core in a transformer, essentially having just two coils, one on top of the other, and the magnetic field is affecting the passive field that's in the car. So as the power, the AC power, creates these fields 60 times a second, that gets transferred into the car. It's then again converted to DC because AC isn't going to charge a battery.
Correct.
It has to be rectified into a DC voltage, and that's how this charging method works. In that picture that we had up there, there was a pad that was on the pavement. There we go. And the car is about to pull on top of that pad and collect the magnetic field in a coil inside or on the bottom of the car. That's essentially how it works.
And I could see, I mean, we've got the technology already for the cars to automatically lift up or go down. If a car senses that it's able to inductively charge, the air shocks simply go down, and then next thing you know, you only have a couple of inches between the car and the coil, so you don't have that loss of efficiency that you have after going over a great distance.
Sure. Should we talk about that funny court case in the 60s with a hippie scavenging power?
Oh yeah, absolutely.
Using this very principle that we just described, when you see those high tension lines that are crisscrossing the United States, again, you have current flowing through those conductors. It's not a coil, but the voltages are very high, and there is a magnetic field that is generated. There used to be a publication in the 60s in the last century called the Whole Earth Catalog. And it was basically published by a bunch of hippies living in communes.
Mm-hmm.
And they figured out that if you build a coil and you set this underneath one of these high tension lines, you're going to be able to scavenge some power from that high tension line. And apparently there was a court case back then that where the utility or power company was suing these hippies that were scavenging power, claiming that they were siphoning power from the grid.
Okay.
And of course, the counter argument was, well, we didn't connect anything to your wire. But again, the court case was unfavorable for the hippies because the technology prevailed, and they were able to demonstrate that there was a negligible decrease in the amount of power that they were siphoning off of this power line. Now, it was low voltage, it was low current. There wasn't, it was nothing to get excited about. They weren't
Right.
powering, anything massive or major. But again, it talks about the technology or the physics that are at play here.
And of course, we were talking about ahead of the show. I'm thinking, okay, what happens to my car if I forget my iPhone on the bottom?
A good point. We talked about
Sitting
that,
on the
yeah.
ground. Is that iPhone going to charge up to 100%? Is it, am I going to have a burning iPhone or, you never know.
With those uncontrolled magnetic fields, yeah, you could be frying your phone if it got too close to that.
That could be an interesting thing. This is an exciting development. I'm really looking forward to seeing what happens over the next few years. I'm really also looking forward to seeing what kind of new enterprise Tesla ends up putting out as a result of this.
It supports the notion that we've been talking about for some time. The whole notion of plugging something in to charge it is kind of silly when the technology exists where you really don't have to do that. And now you get rid of the different standards and the different plug sizes and the big, thick, heavier cables as you go to higher charging rates and all that. With this inductive type charging, that definitely could be the future. And like you pointed out, not only could it be a stationary charging method, but you bury this in the roads, which they're already doing.
Mm-hmm.
Now you're charging while you're driving.
Yeah, to me, it's just a truly exciting technology.
Mm-hmm.
Niles has another comment for you about Ford. He says, Pete, that's right. They do have their moral police, I guess is how I would call it.
Right.
They said, but it wasn't about private matters. They just wanted to keep them sober and healthy.
Good point. Yeah.
Okay.
That would make sense, I suppose. The fact that they could actually be that intrusive, though, is amazing. I'm not sure you could get away with that in today's, with political correctness and
I don't think so today.
and the proliferation of attorneys and yeah.
Well, and the privacy laws, especially the European Union is leading the world in the amount of privacy that individuals are allowed to have now. So Crunch to Grace Hopper on YouTube has another question for us. He says, someone has commented that the 4680 LFP battery has reached the energy density equivalence of the traditional 2170 battery. Is that a game changer if true?
I think so, yeah. And again, we expect battery technology to continue to improve. It's exciting to watch it occur.
Yeah, I think, and Crunch, I think you're also right that it would be a game changer if true. I know that LFP is continuing to improve energy density, and I know the 4680 batteries are continuing to improve as well. So I wouldn't be surprised if that's happening.
Young Line with TikTok says, I own a Model Y. I charge up to 79% for daily use. I will charge up to 95, or it will charge up to 95%. He says, any charging recommendations that can help with the longevity of the battery? Well, we just went through this. The traditional lithium-ion 18650 type cells did not like being charged higher than 80% for maximum life. The lithium iron phosphate, or the LFP cells, can be charged to 100%. And there was an issue with the documentation discrepancy at Tesla, where some of the car's owner manuals would began recommending that you charge to 100%, and of course you didn't want to do that if you had a lithium-ion battery versus lithium iron phosphate. As far as a recommendation with the LFP battery, they're saying you can charge to 100%, and at this point we don't have any evidence that indicates otherwise.
On YouTube, Highlander Apparel has commented, no, McCormick Farm Machine invented it. Look it up, please. Now, guys, I'm thinking that he's referring back to the assembly line.
I think so. Yeah, we can look into it.
Okay.
Okay, yeah, because I had looked a little bit here, and it says Ransom E. Olds was a pioneer of the American automotive industry, and is claimed to have built the first assembly line.
I think Niles has a further clarification. He says Ford invented the assembly line for cars, but assembly line worked in other industries. Ford saw it in the butcheries in Chicago. Interesting bit of history. So that was what inspired him to apply it to auto manufacturing.
Sure, okay. Highlander Apparel commented, I think, to Niles, saying, P.S. I can't spell. That's what happens when you're raised with the Oxford and Webster dictionaries. That's pretty awesome.
So Highlander is actually on our YouTube Shorts channel. So he's holding it down over there. He can't see any of the other comments.
Okay.
Okay.
So,
okay.
Just a heads up, Highlander, you are able to go to our main channel if you would rather see everybody else's comments as well. It's just Gruber Motor Company.
Yeah.
Okay. Thank you. And then YouTube, the universe says, hi. Can we control/prevent thermal runaway using non-flammable electrolyte?
Well, that's some of the newer battery technologies that have been emerging, like graphene, for example, doesn't have the fire risk. Lithium-ion definitely had an issue with that because of the amount of energy density in lithium, but the newer batteries are specifically being designed to minimize that risk.
Yeah, I think in theory you're probably correct that reducing or eliminating, changing out the electrolyte to something non-flammable like sodium ion or potassium ion is going to either prevent or at least greatly reduce thermal runaway chances. Again, talking in theory here, because so many of these battery technologies are so new that you just don't see them in the real world. Any battery could go into a thermal runaway condition. When a battery, nothing is 100% efficient. Everything as far as battery and electricity has some level of resistance. Over time, that level of resistance will increase. Eventually, that level of resistance will get to where it is higher than the battery's ability to dissipate the heat that resistance generates. When that happens, you have thermal runaway. And that would,
Good point.
Doesn't matter what technology you have, it could happen, at least in theory.
Actually, Martin Fisher in Switzerland points out with YouTube, he says, with NEO, you don't own the battery in your car, you just rent it.
Oh, what an interesting point. And NEO, of course, is the one that is pioneering and really pushing for battery changing stations.
And they also pioneered the modular battery swapping stations. Remember, we talked about that in an earlier podcast, because my initial reaction was, look at all of the bricks and mortar construction that you have to do and the permitting processes and all the delays to build these types of facilities that do battery swapping. It turns out NEO simply has a pod that they crane into a location, and it's fully self-contained to do battery swapping.
Oh, okay. Okay.
So yeah, that's an innovative Chinese company. The stock hasn't been doing real well, but I think it has a lot of potential. Again, we don't give it investment advice, right?
Yeah,
guys? So we
yeah,
have to qualify
exactly.
that. YouTube, ROC Electric, and I wanted to grab this one because I grew up in Rochester, by the way. Hi, guys. I live in Rochester, New York, where corrosion from salt is a big issue. Tell me about it. I had a 1963 Ford Falcon that I paid $200 for, and it was so bad, the sides of the doors on the bottom were rusted off.
Oh my gosh.
So cold wind would come inside inside the car. What is your opinion on oil coatings for chassis, and will oil damage any of the components? You're talking about the Z-Bart application, which I fully remember. It was one of the ways you could control rust back there. What they would do is drill tiny holes inside or in various parts of the chassis on the car, and then spray a tar-like substance in there so that when water and salt got in there, it wouldn't eat away at the metal.
Oh, okay, okay.
So the question is related, will it damage any of the components? No, I think a proper Z-Bart application in an EV, first of all, would be unnecessary because a Tesla is aluminum. And salt isn't going to be as devastating or as destructive to that chassis.
So I'm sorry, Pete. He got a Bolt. Said it in an earlier comment that he removed earlier, but yeah, he's getting a Chevy Bolt.
Oh, a Chevy Bolt. Well, I don't know what the chassis on a Bolt is, whether it's aluminum or if it's steel. Well, let's go with if it's steel then, all right?
We'll assume it's steel.
Yeah. The wiring harnesses and the high voltage batteries are typically isolated enough from chassis and from external weather that I don't think you're going to have a problem getting a Z-Bart type application on a car like that.
Great question, though. That's because that type of question applies all across the northern U.S. and Canada and all across northern Europe as well. On Instagram, the real Mugo says Kenya is in the house.
Okay, welcome.
Welcome and good afternoon to you in Kenya.
Still got to get that map showing where everybody's coming in from.
Oh, by all means.
That would be cool. Island Apparel, YouTube says heating is a problem with wireless charging. Okay. Yeah, we have not seen the application of that, at least in our service center. But
just knowing how hot my telephone can get when it sits on a wireless charger, I can only imagine that heating is going to be a real issue.
Mm-hmm.
And when I have a Samsung Galaxy. I don't have an Apple phone, but I think the same thing happens with Apples. You put them on that wireless charger for too long, and they get really warm.
Mm-hmm.
So, the Cat Revenge YouTube from YouTube is on and is asking, where's all this electricity going to come from?
We've got a video that answers that on YouTube, Gruber Motors, and we also thought the same thing. There isn't going, the grid's not going to be able to keep up. This rapid adoption of EVs it's going to be a problem, but we were pleasantly surprised that enough infrastructure is being built and is keeping up, anticipating this extra demand.
Mm-hmm. Bob Johnson on TikTok also talks about wireless charging. He says a big air gap has lots of loss. Plus, you're carrying the extra weight of the coil on board the car.
Good point. Yeah. And you still have the battery as well because that's what the coil is charging.
Yeah, that's, you may end up with smaller batteries and then a coil to go along with that battery. That's, I don't know how much you think a coil like that would end up weighing.
I don't have a perspective there, but it would be interesting with wireless charging on roadways. Yeah, I don't know. I'm going to defer on that one. Yeah.
Yeah, I don't know. I know that the transformers that go in the UPS systems to step up or step down, and those coils can weigh hundreds of pounds.
Well, that's where the majority of weight is in a component UPS.
Yeah.
And, later on they went to switcher type.
Yeah, exactly.
Power supplies, but yeah, in the old traditional where you had 480 input and you needed 208, you had a big 480 to 208 transformer, probably 200 to 500 kVA, and those get pretty big.
Yeah, and they could be several hundred pounds. Highlander Apparel has another comment for us on YouTube. He says, that's why AC is safer than DC.
That's why, I'm not sure what he's referring to there. having worked around electronics all my life, I do know that DC definitely is a bit more painful than AC because you get a little bit of reprieve in between those 60 cycles. And unlike DC, which can actually grab you and hold you because your muscles contract, AC will actually allow you to pull off oftentimes. So
What? Every time we go to this conversation, I get the funniest, what to me is the funniest thought. I grew up in rural Northwest U.S., and one of the things that we would do would be to dare kids to pee on an electric fence.
I've been there, but it was accidental. I was hunting one time, and I didn't realize that in the weeds was an electric fence, and I dropped to my knees, and I thought the earth had ended.
Oh, yeah. You get these kids up from the city in California, and you would dare them. And every once in a while they would. And oh, my gosh, so funny.
But yeah, that was again a safe method because you got one jolt. What was it, about a half second apart, maybe a second apart, the pulse on those?
Yeah, because they were pulses, which was an alternating current.
Right.
And that meant that you had the ability to let loose.
And please, nobody in our audience take the advice of our senior leadership here.
No, you do not want to replicate that experiment, believe me.
Please don't. It's painful. So Niles is back again and it's saying to ROC Electric, I found used automatic gear fluid to work best. It's thin enough to soak through the rust and reach the metal. Other oils and coatings allow rust to form behind it.
Like WD-40. Yeah. Okay. Very cool. YouTube, Highlander Apparel says, tell them about the Uglies book.
Oh, that's probably the Uglies book of electronics. There is an electronics or electrical book, and most of what I've learned about electricity and working with it is from Uglies.
Really? Okay. See, I never heard of it, and I've been in electronics all my life.
Yeah,
so.
yeah. I don't, and trust me, I don't know a whole lot about working with electricity.
Mm-hmm.
I know enough to be a safe homeowner when I make changes. But most of whatever I've needed to really learn, I'll go to the Uglies electronics book and.
Sure. There's a TikTok comment here from False Hopes. He says, if all roads and parking becomes inductive in the future, he says loss won't matter much. It seems like more of a convenience thing opposed to plugging in.
Yeah.
The other thing that we're going to get is a proliferation of people that are going to be concerned about the impact it has on the human body, because you do have a lot of magnetic fields that are going to be floating around. You've got people now that are feeling that cell phones can cause cancer because of the radiation, high frequency.
5G.
Yeah. So now we're back into a lower frequency world, down to 60 hertz in the U.S. and 50 hertz in Europe.
Oh, but can you think about what the conspiracy theorists will be saying?
Oh, yeah, totally.
Oh, my gosh.
There are hidden messages in that inductive coupling that are designed to, do something to you, whatever it is.
Yes.
Okay, guys, we're about an hour and a half. We still got 2 pages of questions here.
ROC Electric from Rochester, New York says, hi, Pete. Welcome. He says, not Z-Bart. He says, lanolin coatings are becoming more popular. Yeah, see, I've been gone for 45 years from Rochester, so they're using lanolin coatings now.
Okay.
Interesting. Yeah.
And then Crunch to Grace Hopper on YouTube says, in reference to inductive charging, Toyota recently boasted achieving a 1,200 or more kilometer run on a closed course fitted with 25% induction coils. Would that be accurate? Do you remember talking about the highway in Switzerland that they're going to make into an inductive charging highway?
I do vaguely remember that, yes.
We talked about this a couple months ago, and the Swiss government at the time said, if we can get coverage of 25 to 30% of our major streets, that should be enough for people to use inductive charging on their EVs and never have to charge. So I would tend to say that probably is accurate, Crunch.
Interesting. Okay. YouTube, Cat Revenge YT, he says, with integrating electricity into road building, That's going to make roadworks a whole lot more challenging. Yes, it will. And of course, in the 4 weather areas where you have to basically repave every year because of the freezing and the deterioration of asphalt, it's going to be a whole new challenge.
You know, there's when we were talking about graphene on Tuesday, one of the things that we didn't comment about that the thought is just coming to me. Graphene, of course, can hold electricity. We know that with solid state batteries. There was talk in some of the articles I researched as well about graphene being able to be used in concrete applications, makes the concrete lighter, makes it more carbon friendly, and makes the concrete into a battery.
That would be fascinating.
That would be fascinating too. So
another thought just crossed my mind. With inductive coupling in the roadways, and like the Swiss you were saying are already starting to do that, where's the revenue generation going to take place? Does that mean we're going to have more toll roads now, that the roads that have charging you've got to put money in the meter before and that doesn't sound attractive to me. Just coming back from Europe, I enjoyed Germany because there were no toll roads. In France, lots of toll roads. And, it's if the lines aren't long, then you can get through there fairly quickly.
Sure. That's a great question and a great point. I'm not sure how they're going to monetize that from a revenue standpoint.
RFID detection. Your car emits a signal, and when it will detect how long you've been on that surface. Anyway, the engineering mind's taking over here. We're going to solve this.
Yeah, we'll solve that definitely. So Highlander Apparel says it's 5,000 and or 6,000 aluminum. Not sure. I'm sorry, guys. Not sure what that one's
don't know
about.
the context on that one.
All right. Ed Prelate says, do you believe solid-state batteries will be the dominant form within the next 10 years? Ed, my simple answer to that is technology is evolving so rapidly, it's difficult to make any kind of predictions at this point. But the exciting part is it's changing rapidly and becoming more efficient all the time.
I think that there is a future for solid-state batteries, that eventually they'll become the dominant kind of battery. If batteries are still necessary in 10 years.
Yeah.
And I think that's a legitimate if as well.
Highlander Apparel also says, I also have a Samsung. Okay. YouTube, the Cat Revenge YT says, thanks guys. I just noticed my 11-year-old changed my sensible first name to the Cat's Revenge. Okay.
That's great. Nulver53 on YouTube says, do solid-state batteries have the same susceptibility to fire as do lithium-ion batteries when there is an intrusion into the battery pack? The quick answer to that is not as much. Solid-state batteries with their solid electrolyte, at least the ones that are being developed right now, that electrolytic compound, which is what is the flammable part of lithium-ion batteries, typically does not exist with solid state. Their electrolyte is a solid electrolyte that is not as flammable.
We had a video of a graphene battery pouch that was mounted on a backboard at a shooting range, and with a meter connected to it. And the demonstration was that puncture would not affect this pouch battery. And they were firing 9mm rounds into this pack from a distance, of course. And you could see the meter was continuing to read voltage, and there was no fire.
That was pretty impressive to see. I remember seeing that video. Highlander Apparel on YouTube says, yes, cell phones should not be worn.
Okay, good point. Niles is saying to our Rochester guest, he says, to clarify, I meant the old fluid drained off automatic transmissions. It has no acid, and it is free, too. Good point.
Yeah. Great point. Highlander Apparel says, guys, told you I'm a former nuclear submarine and automation electrical engineer. That's right.
Yes.
He did tell us that.
I do remember that.
So you've got, he was asking us about putting together that service center. He's got one of those three and possibly two of those three really critical knowledge sets together with electrical engineering, and depending on how much software background he has as well.
Yeah. Well, we're at an hour and a half plus a tiny bit, and it looks like it would be time to wrap at this point. The questions have dried up. We're having fun with this. We really appreciate our audience, and we want to thank you for joining us. This is Thursday, so the next one for us is Jesse and I come in Sunday mornings at 10 a.m. and we bounce around artificial intelligence ideas. If you want to join us for that, bring some coffee and donuts, and we have fun with that one. Very impromptu, unscripted. And then next week, of course, again, Tuesday and Thursday are the EV podcasts, and Wednesday we have the Roadster podcast. Tomorrow, Friday, our Gruber Power Services team is going to do their podcast. And these are the guys that repair critical power equipment, uninterruptible power systems, and data centers. So any of you interested in that, feel free to join that as well.
Yeah, I encourage you guys to take a listen to Claude and Elvis.
That's on their channel, the Gruber Power channel.
Yeah.
Yeah.
And take care. I hope you guys have a wonderful rest of this week.